It's hard. It's hard. Well, we had various ideas where we looked through. One idea, one of the latter ones were neural Turing machines for differential Turing machines. Whether they are actually Turing complete, probably not. How we can search through that space, and there's this research on whether we can invent languages where there's a smooth map between syntax of a program and the semantics, its output. And if there was such a smooth map, you could do gradient descent to find kind of the program that you want, and that would also be short. Those kind of ideas. And then there were other ideas where using programs combined with neural nets, so generative models of programs, output programs that then are executed and somehow iteratively biases the search. So you kind of search a little bit, get a probability distribution over programs that has a high probability concentrated on where your solution is probably is located, and then you kind of iteratively narrow down those kind of ideas. I mean, it's all very vague because it's a tough thing. And the other ideas is whether we can make assumptions about our actually physical universe, where that hold in all generality, in the sense in our universe, that then help to make algorithms to speed up the universal induction problem. So yeah, there are a bunch of interesting ideas and directions to explore. So yeah, I enjoyed the discussion.
About reasoning and learning and fear mongering?
Okay, so I mean, we covered a couple of different things. We covered learning versus reasoning. Is intuition a form of reasoning? And some other ideas. Of course, from Pei Wang Wei, there was some strong ideas about how learning and reasoning are pretty deeply integrated, but there was some general consensus around the idea that reasoning is a process of that is a form that results in learning, because you can derive new knowledge from the learning process, from the reasoning process, from reasoning as a process itself. There's some discussion that learning is with the intention of improvement. So there's an intention or a goal that's a part of it. The other thing that we asked was, does reasoning involve logic, or does it require logic? And there seemed to be some general agreement in that logic doesn't necessarily have to be formal. It can be, cavemen did a form of yeah, there's logic where it's not necessarily a theorem type of processing process. Yeah, so learning, change with an intention of improvement. Reasoning is a process that potentially produces information that wasn't there before. And then we talked about whether or not can one reason with deep learning based approaches, either existing or future ones. And so there was some violent disagreement on that, and well, maybe not violent, but there was some, belief that, say for instance, recurrent nets, because they are Turing complete, that you could conceivably do reasoning with that. Anyway, we just it's the ideas, I wasn't able to fully synthesize them, so anyway, don't know if I did the best job of representing our team here, but it was an interesting conversation.
All right. How about destruction of the world, or how to avoid it?
Yeah, we destroyed the world, but we are not.
You've already destroyed and reconstructed the world. You know this.
Yeah, I think it's not that difficult to destroy the world because if you do nothing, then that probably will happen. But yeah, well, I think after some discussion, at least there was, I think, an agreement on the fact that it would be very beneficial somehow that people understand their own minds in a scientific way, but at the same time that it is very difficult to get that across. It's kind of wondering why people accept that you have to teach math and physics, and that a great number of people resist the idea of teaching how your own mind works at schools, and how that can help you to think in a more ethical way, and how that can help to get more agreement on the actually universal goal function, which actually would maximize happiness, minimize suffering. But one of the reasons why that is the case is because we have evolutionary minds, and these evolutionary minds, they resist actually that they want to be understood in a scientific way, because that would not be in the interest of evolution. So our minds are actually the process of the result of an evolutionary process, and because they are the result of an evolution, they are also optimized in trying to persist, actually, not in trying to be as happy as possible. So we think we are doing that, but underlying we actually are unconscious also pursuing these evolutionary goals. So understanding this and teaching this at schools or whatever you want to teach it is, I think, also we think an important factor in trying to come up with formalizing this universal utility function, knowing that we cannot escape completely our evolutionary mind, so there still will be some ideas how, for example, in the end, finally, we may even have to resort into also genetic genes that actually code us for thinking in an evolutionary way and try to get across it.
So we're back to advocating eugenics again.
Well,
What's so bad about eugenics?
right, but now we could.
Care if you After
Yes.
we modify you, you'll think it's a great idea. Yeah, that's right. I think you've already been modified.
But first we have to understand what we. So this 3-layer. So first we had genetic evolution, then mimetic evolution, and finally we could also have an extra evolutionary step in that we can change our own genes. But first we have to understand that process, and then we could indeed reason about what to change in our gene pattern such that we become better ethical thinkers.
All right, excellent.
Yes, so we were discussing various issues related to sort of semantic perception and action via neural symbolic integration. So
specifically looking at ways to take an infogan type neural network where you have generative adversarial model, where the generative model has some structured latent variables with probabilistic dependencies in them, and do this in a way that the probabilistic latent variables are reasoned on by an abstract probabilistic logic engine, which can then connect with other background knowledge and represent complex dependencies. And we were sort of digging through particulars of how this might actually work and exposing various confusing and unknown things. So one research question that we realize we don't know the answer to is, I mean, if you have a logic engine and you're doing forward chaining inference, you're sampling the inference rules from some distribution and you're sampling premises from some distribution. I mean, what does that tell you about the distribution of the conclusions that you get? Because what we care about is the distribution of the conclusions. What we can control is the distribution for which the rules and premises are sampled, right? So that's a sort of, and we're doing this in the context of a sort of a fairly general, like first order logic theorem prover that propagates probabilities. So that's a sort of new. Well, I don't know. It was new to us. None of us knew of a literature on that. I mean, in simple cases, you can restrict the types of inference rules involved, so it's not that difficult. In general, it's interesting because the dependencies you may have between latent variables, they could just be conditional probabilities, but they could be complex Boolean functions with some overlap or something else. So then doing forward chaining encompassing these complex dependencies is going to give you some weird distributions. So another interesting thing that came up in the discussion was the notion of sort of logical backpropagation in a sense. So if you have a generative network which starts with some logical forward chaining to set the values of some latent variables, which are then used as structured noise in a generative network to generate a picture or an action or something, then once you know how well that generative network did at generating something, you would then backpropagate errors through that generative network. But then how do you backpropagate the errors through the logic engine, right? You're not going to do backpropagate. You could, in principle, actually do real backpropagation through the truth value formulas of the logic engine, but that seems hacky and bad. So what we realized is, I mean, if you save the whole DAG, the whole history of inferences, right? So you know what were your premises, and you know every inference step you did, and you know the conclusions. If you then find the conclusions were wrong in a certain way, you could then sort of go back through that whole tree of inferences and figure out the best way to correct the premises based on the specific errors you found about the conclusion. So for example, if I had thought Pei was a billionaire, and then I found out he was only a multi-millionaire, right? Then that's not just knowing I was wrong, it's knowing how I was wrong. Then if I know the exact series of inferences by which I concluded he was a billionaire, I mean, maybe I can trace back and make an inference of what went wrong. Like maybe that huge diamond ring on his wife's finger was zirconium rather than diamond, right? So then perhaps that was the source of the incorrect inference. So if you keep the whole inference history, you could do a special inference control mechanism, which essentially is like logical backpropagation, which is actually, when we thought about it, seemed like that could be useful in other contexts besides this sort of neural symbolic infogan, and that it somewhat ties in with the idea of knowing your own mind better, actually, because I mean, often in life you not only know that you were wrong, I mean, you know how you were wrong, but of course as humans we're very bad at knowing exactly how we came to some conclusion. But if you're an OpenCog or another logic engine that stored all of the inference steps that led you to the conclusion, you could actually trace back and use the information of how you were wrong in the conclusion to figure out how you were wrong in the premises. And that that in general is something that should make a logic system smarter than people, or really any system that is able to keep a history of how it came to its conclusions and then leverage that history in a judicious way. So that's would be interesting. And I think that's it. That's all the groups, right? Yeah. Hallelujah. All right. Well, thanks to everyone who stayed to the bitter end of AGI17. We were dwindling linearly throughout the day, I think. But I think things have gotten more and more interesting. So next year, AGI18 in Prague will be together with Baika and Neural Symbolic Workshop and maybe some other little AI conferences. So that should be much larger affair. We'll probably have 400 or 500 people. So it should be a different sort of thing. But I think having a smaller conference was also fun. And I'm happy with how this one came out. So thanks everyone. Enjoy Melbourne.